Right, hi. So what I've done is I've typed in a random graph, to be honest, a random cubic. We can see it's quite nice, got a nice lovely shape there. One thing you might want to do sometimes is go into your window and you can try to adjust your settings if it doesn't fit. Because the standard one's good, that's actually what it does automatically here, and often will fit things in, but it won't always. So you might want to zoom in or also, of course, zoom out. So we can now see our graph more clearly again. So you can change the settings and sometimes you'll need to, so just be aware of that. We're going to start by finding one of the x-intercepts. So we're going to find this intercept here. And we do that by going to Analyze Graph and going to 0. So you need to move this to the left-hand side of whatever intercept you're trying to find, and then you go to the right-hand side of the intercept you're trying to find. And we can see here that my intercept is minus 1.9 and 0. And you can move them around because it can get quite cluttered. So try and get used to moving them around. And I do the same thing with all of them. But I'm just going to change something here. So we're going to go into settings. At the moment, I'm on float 3. So if I wanted, for example, to have, let's say, round to 5 significant or 5 decimal places, let's go for 4. 4 decimal places, I would go for fix 4. So float 3 has given me 3 significant figures. Fix 4 is going to give me to 4 decimal places. So let's see how that alters it. There we go. I've now got 4 decimal places. So you can change that as well. Let's just do one more 0 or x-intercept. So I go into Analyze Graph, 0. I'm going to go for that second one. So I go to the left-hand side, I go to the right-hand side, and then I can grab it to move it around because it will get seriously cluttered, this board, in a minute. So I'm going to go through lots of things. Right, okay, let's try it now. Our trace function. So the trace function is really useful. You can type in any value of x, and it will give you the corresponding value of y on the graph. So it's automatically started me off with the y-intercept. So when you type in 0, you will get the y-intercept, which is minus 3. So that's automatic. I should now be able to type in any value of x to get the corresponding value of y. I might be fascinated perhaps by figuring out what the y value is on this graph when x is equal to minus 1. So I've just typed in. When it's in trace mode, you can just type in the x value and it will give you the corresponding y value. So we can see it's indicated by that point. So trace is really useful. So you can find it, a very good way of finding the y-intercept, which will obviously be when x is equal to 0. So it gave that by default. I can go back to it now so we can see when x is 0, y is minus 3. So it's really good for the y-intercept and getting any corresponding values of y when you know the value of x. So it's super useful. Analyze graph again. Let's find a minimum and a maximum. So the minimum is obviously a lower one. This is very similar to finding a 0. You go on the left-hand side, you go on the right-hand side, and there is my minimum. So that is the lowest point on that minimum point there, that turning point. Let's find a maximum as well. You'll be amazed to know that we go to maximum to work this out. So I go on the left-hand side of my maximum, I go on the right-hand side of my maximum. And lo, I now have my maximum, my x value and my y value of my turning points. Again, this is really useful for analysis. Okay, so can we imagine this scenario? So now I'm going to try and solve for this equation. So I've got the same function I've already drawn on the left-hand side, and I'm going to find out where it's equal to e to the power of x. So we can do that by substituting it or writing in a second function. So I can go to graph entry and edit. So I've got a third graph there. And I'm going to type in e to the power of x. So you have to use the actual e to the power of x function. I don't think you can use e itself, the letter e, because then it's just going to give you a random constant. And then press enter. And what we'll see is we've got quite a few intercept points here. So quite a lot of solutions. And this is why NSolve doesn't give you, only gives you one solution. So that's why sometimes it's much better to graph it so you get more accuracy. Okay, so here is my graph, and I've got some of the intercepts there, but not all of them are showing up, so we're going to have to zoom in a bit later, I think, to find those intercepts. Right, so we're going to go in to analyze graph again and intersection to see where they meet. And again, you go on the left-hand side, and you go on the right-hand side, and you see it's already picked out my intersection point there. So the x value of the intersection is 1.88 blah de blah, and the y value is given as well. So that's all you need to do. So just do it again, one more, analyze graph. Intersection. Here's the second place where those two graphs intersect. So you go left-hand side, you go to right-hand side, and you're given the intersection point. We could zoom in and out because there are more. We could just about look at that one. But just to make sure there aren't any other intercepts, it's a good idea to zoom in and out. Otherwise, you can miss them quite easily. Right, let's look at NSolve then. And I'll probably use the same equation, bizarrely. And we see which one of these values we get. So in order to use NSolve, we're going to go back to on, and we're going to go to calculate, I believe, and then menu, and then algebra, numerical solve. So numerical solve. And we just type it in. I've completely forgotten what the equation was. So it's 2x cubed plus 2x squared. Tried to make it easy to remember. Failed there. Sorry. Let's see if I can be bothered to edit this part, or you're going to actually have to listen to me, look at me, type in the whole thing. Apologies if I ended up being too lazy to do that. So minus 3 equals, and then we've got to go, remember, to e to the power, the actual e there. You see the little red thing went, whatever, highlighted. Right, and so there's your equation. And then you have to put a little comma in, an x, to say, hello, I'm solving for x. And then you press enter. So it's given us one of the solutions. So remember, that's the problem, really. Minus 0, so that's the x value, one of the solutions for x, minus 0.64 blah-de-blah. Let's go and check. Oh, that didn't work. Oh, no, I don't know. Let's go back into graph. Do we have to? And let's sure it's right. I'm sure you're fascinated to know. Hopefully my graphs haven't all disappeared, though. Let's have a look. They might have done. They haven't. So there it is, minus 0.6458. So the same solution. But you only get one from NSolve. Right, another really useful thing that we can use is also the simultaneous equation solver. So I'm probably going to make up a totally random simultaneous equation. Let's go into that. So that's in algebra. So I'm going to go back into my calculate, and then I am going to go to simultaneous equations. So let's have a look at that. So we're going to algebra, solve system of linear equations. We're only going to do ones with 2. So I'm going to press OK, and I'm going to make up a couple of random simultaneous equations. So you can see our variables are x and y. So I'm going to go with my favorite, which is 2x plus y, 3y equals 4. And then put in a second simultaneous equation. So let's say, I don't know, x minus 5y equals 7, and hope these actually do meet to give us something to solve. And there we go, they do. So you can use this to solve simultaneous equations with ease if you haven't done that before. That's all I'm going to go through now, but I will add some other things later. Okay, thanks.